we decided to go our own separate ways. And we did well by it. I'm going to start the live stream as well. For anybody who's late, tough luck. Everybody should be good to go. I am starting a local recording as well, and we are live. Hello, everybody on YouTube. Hello, amazing hackers on Discord. I hope you had some time to rest because I sure have, and I'm ready to torture you some more because I haven't rested at all. I lied to you. I made labs for you. We're not going to be bored at all. So if you're watching at home, you know where to find these labs. I will link them as well in the chat, and I have also linked a coupon in the chat, an early bird coupon that is for a few days. That's only valid for the first 3 days, so make sure you take advantage of that. For now, we're going to go more into API hacking itself because, well, what would we be without practice, right? So, to celebrate this joyous occasion, I have designed some rat code, and I'm going to again do the massive solid of giving you the source code, so you won't even have to really think of all of the exploits. They'll literally be staring at you right in the face. I'm going to first start this up, and while I do that, we can go to the APIs directory of labs.experts.com, and we can show you the code. I'm going to link this as well for anybody at home who's watching. Yes, hello Hackershood, good to have you back as well. And everybody there in the Discord who's watching as well. If you want to participate, this is what the code looks like. So for anybody who doesn't know, SQLite is a light SQL version, so that means that it's portable in this case. It spins up its own SQLite exploits DB in this case, and we can do something later with that. We can also see a class for the user being defined with a username and an identifier. We can see a few routes, 3 to be exact, slash SQL injection with a get method. So that means that we should just be able to copy and paste this into our browser, right? That should be normal, that should be expected, but can we? That's the question. And then we have user ID with the request.args.get ID 1 by default apparently. And we have a query here, select star from users where ID equals user identifier. That user identifier coming, of course, from here. And then we have the results being written to a variable, and we return those results in a dictionary. Next up, we have a route cross-site scripting. The name says it all. We have a get and a post method right here, and we say if the request method is post, then we're going to render a form, and we're going to render a template saying hello username or whichever you entered. It's going to display it. And we, of course, if we don't get the request method being post, we return the form on the page. Once the return has been hit, we cannot hit another return, of course, meaning that once this has been hit, we can never reach this code, so it will only display that if you've entered something on the screen. Next up, we have the insecure file upload route, and this name again says it all. We have a get and a post method. But you know me, I wouldn't be myself if I wouldn't make you suffer at least a little bit. So what we're going to do is we're going to exploit this manually, and then I'm going to leave it up to you to exploit this through Postman. You can also see something new here. Debug pin, and it's set to something very, very, very easy to guess because I'm a lazy ass developer who put shitty code in production. And it says app.run host equals, and then your host itself. That's your machine. It's going to start it up on the internet, and then on this port, of course. If we look at the IP address itself, yes, thank you very much. On YouTube, that's different, of course, but here on Discord, that should be totally different. But you have been able to follow along on your own screens. Luckily, I've sent that code. If you haven't, just read it for 1 second. It should be very obvious. And we are starting up at port 8345, which we have right here. And we have those three routes slash SQL injection. So let's see if we can actually achieve that slash SQL injection. Yep, we can. We can also go to slash XSS. Oh, and I will, of course, paste this link in the chat as well. Hello, Nelson. Hello, James. Hello, Navid. Good to have you here, my friends. And we have slash insecure file upload. The Netherlands. We were in the Netherlands today, by the way. We went to a theme park, Toverland. And here we can upload files. Upload. File not found exception. Up until this point, okay. But that's not what we're trying to achieve here. I'm trying to show you unsecure file uploads. So that means that you can basically, well, upload anything here. You've guessed it. But now I've shown you how to do this manually, at least to a degree, to get to these paths. I want you to try to do this through your, well, first of all, SQL injection. You can try to get some sort of SQL injection through your browser, but you know me, I prefer Postman. So let's try this through Postman, shall we? How do we do that? We copy it. We say we make it. Let's just add it to. Let's add a new collection just to make things well around it. And let's say that this collection is going to be called rat code. And we have a request that we can make to this address. We can send that over. We have results here, but remember this is code. The source code said that if ID equals something else than 1, we get other results. So we say maybe ID 0, but there is no code in this, of course. Now, how do you exploit SQL injection? First, you find it, of course. So you try to enter something like single quote, double quote, and then we can send this over. And we can see that we already have some issues popping up here. So what could that be? And could we exploit this further? Just give it a few moments. Try this yourself. Add this. I'm not going to give you more than 2 minutes because if you've seen yesterday's stream, you should be well adapted to this. Try to, if you are well adapted to this, try to add your variables. Remember, your variables have different scopes. Can be on collection scope, can be on the request scope, it can be on your workspace scope. Workspaces can be shared with other people. Remember, I can share this workspace with up to 2 people in the free version, and I can also just make not just a collection like we see right here, but I can also make a monitor, even a mock server. I can set up my different testing environments, and I have my APIs here, which I can set up as well. And then a history of the calls that I've done. So not super hard tool, but you should always remember if you have a environment and you change something here that you also save it. Otherwise you might have some problems in your calls itself. This also goes if you're chaining multiple calls, for example. You always need to remember that if you make a change somewhere, you need to save it or it will not persist. So that means that if you make a change in a call right here, it might work because right here I'm making my change and here it's going to work. But when I run this entire collection, it might not work at all anymore. And that is because I haven't saved it. I'm running I might need input from this in a different request and it might fail for the next request because I think it is returning the right response, because when I click send here I am getting the proper response, but the next request doesn't see the same response because I haven't hit save. It's just a curiosity teaser that you pick up while you work with this program. Nothing that you have to be too worried about, but just do remember to always save properly. Alright, my friends, I think that was pretty easy, right? To just add this, you add this as your get request. Where are you? There you are. And there you are, you add this as your get request. I cannot paste that in here, that's not a huge problem, but that should be more than sufficient. It's a SQL injection, so it's not that hard. For the cross-site scripting, if you go to slash cross-site scripting, you can see different things though. If you click say hello, okay, this is pretty easy. You can do cross-site scripting on here because we have HTML injection. We can take that one step further and we can say on error equals alert. And we have our basic cross-site scripting already. But can we do this through Postman as well? I don't know. Let's find out. So let's go to slash XSS because that is an endpoint that we have as well. And remember that we're not making a GET request here. We're making a POST request. So we have a type here and a name is name. So once we do know that, we can go to the body form data. We can say name and we can say the value is going to equal, remember, image source equals x on error equals alert. Should you do this through Postman? No, not really, of course, but you can insert your attack vectors through Postman. That is something that you have to take into consideration. So let's make that post. Oh, hello, image. It has a basic reflection going back here. So, oh, that's fucked up. Let's visualize this. You don't see the pop-up in here. Why is that? Because that is never meant to have that pop-up. This doesn't have JavaScript. You need to keep that in mind. But if you do see reflection like this, it's worth trying. Often you'll see this with stored values, where the stored value is entered into the database in this way. So it is something that you have to keep an eye out for. And then we have the insecure file uploads. If I want to know what this API request looks like, I can always go to the network tab right here, and I can zoom in a little bit for you as well. Let's upload a file. Let's choose one and let's upload it. And we can see here we have a insecure file upload with a binary file. If we look at the source code right here, we can see that we do have our image, also form data, file name that we have right here, and the content itself. And of course, if we look at the, where is it, the payload? One second. Oof, it's okay. It's not a huge problem, but we are uploading a binary. That's what you do need to know. So what does that look like? We can go to slash file upload slash insecure file upload as well. But you see that we do need to provide a file, and it was just a form request that we made as well. So we can just put here file, and right now we don't have a value filled in, because this isn't the proper content type. We need to set the proper content type as well. But above all, we need to upload a binary here. We need to set a binary. So it's a little bit different for this API. Keep that in mind, that sometimes you're working with different types of input as well. Now let's bring an end to this lab and let's go to redcode2.py. And redcode2.py is going to live in the same location. So we have redcode2.py. You can also find that under the API testing labs. Here's the source code if you would like to follow along on your own screen instead of mine. That's no problem. There we go. And if you have questions, by the way, don't hesitate to ask them. But here we can see we have a path traversal request where we can get a specific file with example.txt, but I don't want you, of course, to get example.txt. I want you to get secret.txt. Secret.txt is just in this folder. The same folder right here, secret.txt, as you can see. I just want you to find that. Now, if we go back to those API labs and we go back to the source code, what do you need to do? You need to set your file parameter as secret.txt. The second one, command injection, is what the name says. You can inject OS commands. That does mean that you can make a reverse shell as long as this lab is online. That is why this lab is not going to be online after this webinar. So if you want to make a reverse shell, do it now. We're restoring the server afterwards anyway. So knock yourself out. For the open redirects, Well, the name says it all. It's a basic open redirect. It takes any URL and it's going to redirect you there. That is now running. So give this a shot. You go to /path reversal and you can say file equals secret.txt. And here it's going to say file not found. That's not a huge problem. We probably need to be in the right path for it. Requested URL was not found in the server. Not a big problem if we go and look at the file itself. Ooh, and now I'm going to destroy it for you. I'm sorry. Let me just not fuck with this anymore. But here we do see secret.txt, so it's probably that we have to do proper path reversal here, and we have to go to /var/www/html/labs/secret.txt. You get what is supposed to happen here, of course. I'm not gonna fiddle around with this for too long. You also have the full source code, so feel free to try this one out on your own server fully. But moving on to the next point that we had in here, that's going to be a little bit more of a dicey one, because it is going to allow you to execute OS commands. Here you can see hello world. Why does it do that? Because the OS command that has been sent out was echo hello world. That means that if we say $CMD $CMD equals who am I? Oh, apparently this is running as root, so you know what that means. Once you have a reverse shell connection made, you're basically in as root in this server. How do you make a reverse shell connection? That's a bit outside the scope of this course, but feel free to check out the channel for some videos on that. For the open redirect one, we can do /open redirect, and guess what? It's going to request a URL, URL is, let's try to get it to go to labs.hexpert.com, and we have to add a protocol as well. It's redirecting us, but it's not properly redirect. Oh, because we haven't properly spelled the name. It's not Hexert, but Hexpert, of course. But that's what the open redirect is doing. Now, what I haven't shown you yet, and this is something that's important to talk about as well, is that debug endpoint, because we've seen that debug is active, but what is workzug debug pin? What is that, and how can we abuse that? Because if you do see that workzug is active, you can make connection with it. It's not super hard. You just have to know where to look for it. I'm not going to give you the full solution to it, but it's as simple as making connection to the right endpoint, and then and of course you need to enter the right pin. Why is it secure by default? Well, it's not secure. You should never have this enabled in production. So if you are on a pen test, make sure to tell your customer to disable this when they move to production. But why is workzug so important, or why is it such a big one? Because this is a full debug console. It means that you can execute any type of Python commands that you want. A Python reverse shell isn't that hard to achieve. So if you find this open, try some easy pins and passwords. It's always the same structure, so just try some easy passwords for it, and just try to see if you can make a connection, a reverse shell through Python. I want to move onwards to redcode 3.py though, because we have more to exploit, and I would like to go to bed on time today. Oh wow, yeah, I know, 11 p.m. That's not really in time, but that's beside the point. /CSRF. We need to start that first though, because otherwise you guys aren't going to find that on the server. So, alright, there we go. It's started up now, and I would implore you to do this yourself at home, by the way. But here we can see there are some CSRF issues. If I go to network, and here of course make a post request to the page CSRF, it says action completed, and here I don't have in my body, I don't have any CSRF tokens or anything. There isn't really anything. It should at least have a CSRF token. That does mean you can exploit it as well. If we look at the source code itself, we can easily see if request.method is post action complete. So let's just give that a shot, shall we? Because it's not hard. We already have it partially here. If we go /csrf, we make a post action complete. So that is a CSRF exploit. Now, if we go to that would be if the user would have to be logged in for this protected resource, of course. That's an important caveat to mention. But we also have /x6e, for example, and here you can perform an XML external entity request. I'm again going to leave this up to you because I don't think it's that prevalent anymore. Just know that SOAP is XML request, so SOAP can be vulnerable to this to a degree. It's in there, it's available. And then we also have the JWT manipulation vulnerability available to us. Again, not going to go too deep into this. If you want to know more about this, check out my YouTube channel. But there are certain ways you can exploit JWT as well, of course. Let's move on to rat code 4.py. Here we can see that we have course misconfigurations where we have access control allow origin set to origin and access control allow credentials to true. All this is going to do is going to give you wrong headers, of course, in your response. These course headers should be set way more strictly. For the SSTI, here we're going to have a server-side template injection. I'm not going to fully exploit it, but I'm going to show you the 7x7 trick that's so familiar to most people. And just for good measure, we have a second reflected cross-site scripting in here. So let's show that code for a moment running on the server. We should have that up now. If we go to the /misconfigured course endpoint, we can see those course headers return in the network tab here, in the header tab, in the response headers. We can see access control allow origin star. It's basically a wildcard to everything. So that's why these headers are wrong, of course, they're misconfigured. And if we go back to the source code, we can also see, sorry, that is not the correct source code that I need. This one, of course, that we have the /SSTI endpoint. Now, how can we see this? I think it would be nice if we just exploited this through Postman just to change things up. Now here we can see that we have, if we go back to the code, only the get available. So it's going to require us to have the argument template set. So here we have, it's going to render that template with the name user setup. So if we just go to this endpoint and if we don't do anything else through the get method, we can see that it says hello user. We can find that back as well. Here, if we look in our source code, name equals user. So let's try to exploit that, shall we? Question mark template equals crap. Template equals 1. That's a different story already. Now let's try to add that $sign. Where is my $sign? There we go. 7 times 7 and then close my curly brackets. That gives me 49. Now let's try that in here. Question mark template equals 7 times 7. Oh, that is 49. So SSTI is possible in this instance. Not good, of course. That is something that we need to investigate, and we need to see what templating engine has been used and how we can exploit it specifically. When we talk about reflected cross-site scripting, well, I don't need to draw any pictures there. That should be pretty obvious. I think we should go onwards to rat code number 5.py. There we go, and here we can see obviously that we have an IDOR endpoint, again only with a request method of a get. So if we go to /IDOR, we can see that we have that ID here, question mark ID equals, and then say 1, for example. Here we can see something has not been found because I haven't started it up yet, of course. I need to remember to do that, otherwise you guys are gonna have trouble finding these things. Let's see. Yeah, sorry about that. My keyboard is a little bit annoying today. Or maybe it's the server itself. Maybe you guys are already hacking into it. There we go. And then we cd to labs, and then we cd to APIs. Let's see. So this one is still open. Oh, there we go. It's finished already. So let's start up number 5, shall we? Ooh, red code 5.py. Can open because we're in the wrong directory. We need to cd to labs, and we need to cd to APIs. And here we can try to start red code 5 again. There we go. And here we have that IDOR. If we do that and we try that in Postman, we can see that we grab public data here. Well, this should be private data. That's our IDOR. We have that's what we saw yesterday as well. In this case, a broken object level authorization issue. Slash rate limiting bypass. Well, again, I don't have to draw any pictures there. There is no rate limiting at all on any of these API endpoints. And we have missing function level access control as well, with a get and a post, where it says if request method equals post, it should return admin action performed. So let's give that a shot, shall we? We should just add this and change that to post, and then we're going to make a post to this endpoint, and it says admin action performed. Not rocket science, of course, but you have to know, because these are all vulnerable APIs. They're explicitly vulnerable, and it's really easy to find out why they're vulnerable, what's going wrong here. I mean, the endpoints literally say it. It literally says it: header injection, host header injection. So it should be pretty obvious, and the code is available to you. But if you're testing this, remember once again that you're testing this with a mindset of, oh, I'm a hacker, okay, so far so good, but I'm doing this from an outside, usually blind perspective. If you have access to the source code, even better. But believe me, it doesn't get any less confusing, it gets more confusing, because the more literal information you have, the more confusing it is to find your way through that maze of spaghetti code sometimes. For this host header injection, you need to just add a header host, and that header is going to be requested, and it's going to say X inside add. It's not really going to do it, of course. And then we have header injection, where we have a header that it's expecting header value, and the value is going to be default, and here it's going to inject that value in a custom header. So not a hugely difficult endeavor to undertake. There we go, and then we have 7.py, where we have server-side request forgery, where the server is going to make a request to the URL that we enter, by default example.com, but we can have that be an internal address as well for servers that are only accessible internally. We can also go to the slash parameter tampering endpoint, and here we have a parameter discount 0.0, original price 100, and we can see that the original price is done times 1 minus the discount. So here we can, of course, tamper with that parameter of the discount, where we should not be able to change this. It's not even about the fact that it is much higher than it's supposed to be. I mean, we can set it to 100% and get things free here. Error-based information disclosure, below that it's going to request for a secret key, and if it doesn't find that, if the secret key does not match the one that is set in the app config, this one here, it's going to return invalid secret key, and it's literally telling you what's wrong. That is your error-based information disclosure right here. So that is 7 more APIs, or 8 I should say. 1, 2, 3, 4, 5, 6, 7, 8. Why the hell did I get 8? 7 new APIs. I'm going to stop the live stream on YouTube after I answered all of your questions, of course. And then I will continue with the CNWPP live class through the Discord server because you guys deserve some more personal attention, by which I mean personal torture, but let's not tell that to anybody, especially not the whole internet. But let's see, we do have some questions here. There is a recording indeed. If you go to the YouTube channel, there's a recording of the last session available. I'm sorry if you guys missed that. Love you too, guys. Thank you so much for coming, everybody. I really appreciate it. If you guys want that first video, it is available up on our YouTube channel, so feel free to head over and have a look. And there is a full API pen testing playlist available with 18 videos, assuring that you will not be bored your Sunday. Thank you so much for joining, my friends. I really appreciate it, and I will see you in the next one. Bye, amazing hackers. There we